Hi class, we meet again to resume the undone business. This time we will learn about temperature and its unit system. Firstly, let us define what the temperature is. Temperature is a measure of hotness or coldness. However, we cannot assign numerical values to temperatures based on our sensations alone. Fortunately, several properties of materials can be used as the basis for accurate temperature measurement. The commonly used is mercury in glass thermometer. Temperature is also measured by using several other temperature-dependent properties. When a body is brought into contact with another body at a different temperature, heat is transferred from the body at a higher temperature to the lower temperature until both bodies attain the same temperature. At that point, the heat transfer stops and the two bodies are said to have reached thermal equilibrium. The equality of temperature is the only requirement for thermal equilibrium. The zeroth law of thermodynamics states that if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. By replacing the third body with a thermometer, the zeroth law can be restated as two bodies are in thermal equilibrium if both have the same temperature reading even if they are not in contact. What temperature scales are? All temperature scales are based on the freezing and boiling water points, called the ice point and the steam point respectively. The temperature scales used in the SI is the Celsius scale, formerly called the centigrade scale. The ice and steam points were initially assigned 0 and 100 degrees Celsius values, respectively. The temperature scales used in the English system today is the Fahrenheit scale. On the Fahrenheit scale, the ice and steam points were initially assigned as 32 and 212 degree Fahrenheit. These are often referred to as two-point scales since temperature values are assigned at two different points. In thermodynamics, it is very desirable to have a temperature scale independent of any substance or substance's properties. The thermodynamic temperature scale in the SI is the Kelvin scale, named after Lord Kelvin. On this scale, the temperature unit is the Kelvin, which is designated by K. The lowest temperature on the Kelvin scale is absolute zero or 0 Kelvin. The thermodynamic temperature scale in the English system is the Rankine scale, named after William Rankine. The temperature unit on this scale is the Rankine, which is designated by a capital R. The absolute gas temperature scale is not a thermodynamic temperature scale, since it cannot be used at very low temperatures. Thus, the thermodynamic temperature scale can be assumed as an absolute gas temperature scale that utilizes an ideal gas that always works as a low-pressure gas regardless of the temperature. Now, let us compare the two unit systems. The comparison of various temperature scales is shown here. The Kelvin scale is related to the Celsius scale by the following relation. It is common practice to round the constant to 273. The Rankine scale is related to the Fahrenheit scale as a given form. And it is a common practice to round the constant to 460. The following equations relate the temperature scales in the two unit systems. The figure illustrates the comparison of magnitudes of various temperature units. The following equations relate the temperature difference scales in the two unit systems. To describe how the conversion of various temperature scales is determined, let us comprehend example 1.4. This problem deals with temperature changes, which are identical in Kelvin and Celsius scales. Therefore, by using the following expression, the rise in temperature in Kelvin is 10 Kelvin. The temperature changes in Fahrenheit and Rankine scales are also identical. They are related to the changes in Celsius and Kelvin scales through the following expression. The temperature difference in degree Fahrenheit is 18 degree Fahrenheit. As stated here, the units degree Celsius and Kelvin are interchangeable when dealing with temperature differences.